Christina, is my sound working?
Yes, I hear you well.
Okay, let's just get going.
Yes.
Okay.
Kimberly, the floor is yours.
Okay, thank you, Christina. Thank you all for joining us today. I'm so happy to be here to talk about measuring embodied carbon, hopefully to give you information and provide you with some answers to some burning questions you might have. So I'm going to start with just getting us on the same page with definitions about sustainability and climate action, provide you with the drivers, why we should do this, and then get into the how with the resources and tools, do a quick case study, and then jump into circular economy and hopefully have time for questions at the end. Okay, but let's get started with sustainability and climate action. When we talk about sustainability, just going back to basics, many of us have heard of the triple bottom line or the 3 Ps, people, planet, profit. What we're trying to do is balance economic viability, social equity, and environmental protection as we develop things for the future. So it's a pretty common definition, but I just want to make sure we all agree on what it is. It's not just environment, it's not just carbon, it's more. And we want to try and develop in a way that thinks of all these things at the same time. You can see it's imagined as a pretty small target. Let's find out more. So when we think of sustainability, I like to use the UN Sustainable Development Goals as a framework for this. Why we like these SDGs is that they're universal, meaning they're accepted by and signed onto by every country that's part of the UN, so all across the world. And also they're holistic. So they do cover all 3 parts of sustainability and break it down into pieces for us. But when you look at this, you're probably thinking, okay, well, there's still 17. So where can I actually start? And today I want to propose to you to start with one, and that's climate action. I want to make the case for you why you should do this as an engineer, as a contractor, as a company. And I'm just going to go through why I think this is a good place to start. So one more piece of background. When we talk about climate action, we're mostly talking about reducing carbon emissions to help prevent the worst case scenario for global warming and climate change. What that means on a basic level is we have solar radiation coming from the sun. The thing to note about that is it's coming through in short waves.
When we talk about climate
it gets
action,
to Earth, not all
mostly
of it,
talking
but most
about
of it,
reducing
and it's then
carbon
radiated
emissions
out. When it's radiated back from Earth, it changes to longer wavelengths, the infrared zone of wavelengths. What that means is those longer wavelengths go back out to our atmosphere and they interact with the greenhouse gases that are there. The more we increase things like carbon dioxide, a key greenhouse gas, the more those longer wavelengths interact and re-radiate back to Earth. And that's what's really happening, and what we're really worried about is that heat trapped and re-radiated. And if you've seen this chart before, then you know that carbon dioxide in very recent times has increased after the Industrial Revolution at incredible rates to levels that haven't been seen for millennia. So that's what we're talking about when we talk about reducing greenhouse gases and why it's affecting the climate. So when I say climate action should be the place where we focus, I think of this infographic provided by Phil Ho et al. This is really a great way to map out how focusing on climate action may seem like one small part of all the things we could do when it comes to sustainability, but it actually has really broad impacts. I want to make that case for you. So when we think of climate action, we can break it down into pieces. So one is strengthening resilience and adaptive capacity to climate-related disasters. And by doing so, we can impact SDGs 1, 2, and 11 as well. So as a geotechnical engineer in the geotechnical industry, you may say, what does that mean? How am I actually strengthening resilience and adaptive capacity? And why should I do that? Well, here's an interesting infographic from First Street, a company that does risk assessments for insurance companies. And what this chart is showing is that for flooding, this is saying how things have changed from a 1 in 100 year return period. So places in white, the return period for a flood event, a 1 in 100 year flood event, is still 1 in 100, 1 in 90 years. But in many places, and you see along coasts and you see places where we have a huge population center, that 1 in 100 year return period is now 1 in 10 years or 1 in 5 years. So things are increasing. Climate disasters We're seeing them in the news all the time. They're increasing, and they're increasing where people are moving to as well. So as engineers, we need to think, okay, we used to design for here, for this white area, but that white area has now become almost dark blue in some key places where we live and design. But as a geotechnical engineer, what do we do about that? What are we building that addresses this climate resiliency and climate adaptation? One of the key things where you'll see this is coastal resiliency, preventing the flood interaction with coastal waters. So as an example, here's a case where Keller was working on the East Side Coastal Resiliency Project in Manhattan. This is to prevent the worst case flooding, particularly after we saw what happened with Hurricane Sandy, with $70 billion of damage from that hurricane. So at the East Side Coastal Resiliency, we have a place where Keller and the geotechnical industry were providing 2,500 aggregate piers and 500 micro piles to support this new infrastructure that will help prevent the worst case damage. And you can imagine with that level of damage, how much poverty and how much damage to society was in that area all along the eastern seaboard. So now we as geotechnical engineers in the geotechnical industry can actually help prevent that from happening again. Another place that climate action and carbon reduction comes into play is promoting mechanisms to raise capacity for climate planning and management. So we have to build the workforce of tomorrow, right, to do this. And when it comes to promoting capacity, we can think about what does our future workforce look like? And how are they going to be trained for the skills to design and build the things of tomorrow that are coming down the pipeline? So a way that Keller is doing this is working with Revolution Workshop in the Chicago area. Revolution Workshop serves the underserved communities of Chicago. And basically, they're taking people that want to work, just need the skills, and they're training them to then join the workforce, join the unions as tradespeople to build the future workforce, and doing that in a way that's inclusive and respectful to all. Another way climate action can be implemented is through partnerships and policies. Having good governance is key to saying to knowing that we're actually doing something for the future. So if you work for a company that says, hey, we want to be net zero by 2050, someone like Keller, we need to know Keller's really going to do that. How are you going to follow through? And that's a key component of climate action and the UN SDGs as well, as that transparency. So an example of this is issuing science-based targets. At Keller, we haven't done it, but it's something that's on our list of things to do. Science-based targets are really incredible. This is where companies say, hey, we're going to set our target and commitment. We're going to get approved by the Science-Based Target Organization. And this means we're going to track and report what we're actually doing. So we're not just going to say we're going to be net zero at 2050. We're going to show you the path on how we're going to get there and be transparent about it. And that's really powerful for your stakeholders, also for your employees. Another way we can address climate action that impacts other SDGs is building knowledge and capacity to meet climate change. So I talked about building up capacity in an inclusive way, but also just building up capacity in general of our workforce, because things are changing. Like I showed you with that map from First Street, the conditions to which we're designing is changing. So it's important to make sure our own employees at our companies are upskilled and have the knowledge they need as we're addressing these changes and things are moving in a new direction. So ways you can do that are, of course, attending this webinar today. Keller and the Geo-Institute put on a sustainability series this past year over the past few months, and you can use this QR code to link to watch the 5 webinars in that series. And then also there's conferences like annual conference held in Amsterdam focusing on foundation, decarbonization, and reuse. All of the materials for that conference are available online. So we can take advantage of these things that are free, but also there's amazing programs that you can send your employees to really upskill them and allow them to be prepared for the future work we're going to see. And the last thing is really directly cutting carbon. And when we do that, we can impact so many of the other SDGs as well. So if we integrate these climate change policies and measures into our companies and our workflows, we can really make an impact, and we'll talk more about that today. But here's an example of a Keller project in Germany where the owner really drove this, said we want a carbon neutral excavation and foundation solution. And it was a lot of work for our teams, but having that owner say this is important to us allowed our teams to spend the time and get this done, ultimately having a 50% reduction in the carbon of the foundations based on a reduction based on what was originally proposed. So by doing this, we're using less resource, we're oftentimes reducing pollution, making it better for our workforce and a safer solution as well. So now you see all the ways that carbon reduction can impact sustainability. So I think that makes it a good place to start, but there also are specific drivers as well. So this is in the EFFC DFI Carbon Reduction Guide. This is from the European Foundation of Federation Contractors and the Deep Foundations Institute. And it's just highlighting all these different ways that we see the push for low carbon solutions. So for example, legislation's a big one. We have a lot of up and coming legislation, things that have already been passed or in the works. We have the SEC rules on reporting scope 1 and 2 for major corporations that are publicly listed. We have the federal acquisition regulation, which was requiring federal contractors to have an actively report their scope 1, 2, and 3 emissions. I'll define those scopes in a little bit, but basically report their carbon emissions, also the risks associated with climate change and science-based targets. Many of us wouldn't be major contractors for the federal government, but we often work for those federal contractors. So that means they may need that information from us. Also, California is leading the way with sweeping climate measures. Aside from just climate reporting, they're definitely the state that's leading the way, is saying they want major corporations that operate in California to be reporting their carbon emissions. That is a funded program and holding up in courts, so that is coming. But also just more legislation beyond just carbon reporting, things like requiring whole building life cycle assessments for large structures that are applying for building permits in California. So this legislation, although many of it seems like, okay, maybe it's in Europe or somewhere else, it actually is happening right here in the United States. Also, there's financial pressure. It can be something like companies trying to get sustainability-linked loans. The restrictions on that are getting tighter and tighter, but it is a way to get funding, is saying this is a sustainability project, or we're going to meet sustainability goals with this project. And also, a lot of investors have sustainable investment policies, so that's something to think about from our owner's perspective that we might be working with. And also, we have the Inflation Reduction Act. So this is tying federal funds to new investments, which includes things for requirements for things like low carbon materials. So this is all kind of tied together when it comes to funding. Also efficiency. So drivers don't just have to be things from the outside, but also we want to be more efficient oftentimes, right? That's cheaper, it's a better solution for us and for our clients. So one thing that we can think about when we're thinking of efficiency is things like battery energy storage systems. So using hybrid generators, they can lower the fuel consumption, improve air quality. Like we said, lowering carbon can also do things like improve life on land and the other SDGs. And also they reduce maintenance. So this is just from United Rentals showing that even though the cost of the rental could be more, you're typically going to make back that savings because you're not going to pay for it in gas and maintenance. Another driver is employee demand. And this is really interesting outside of our industry, but Lego is saying, you know, it's so important to our employees. We're going to link sustainability targets to the entire salaried workforce for their bonus structure. And they're doing this to attract and retain particularly younger generations. So that's something interesting to think about for the geotechnical industry. Then we have things like managing risk. A lot of this has to do with the framework, the Task Force for Climate-Related Financial Disclosures. This is a really key piece of key framework that many companies that report publicly, they're publicly listed, will report to. It's required in many European jurisdictions, particularly with new legislation coming out of Europe, but also in the California legislation as well. And what this is saying is a company needs to really assess how climate change is going to impact them in their operations and in business decisions that they make from a risk and opportunity standpoint. So Keller actually reports to TCFD. So what this can look like is running different scenario analysis. So for example, this one would be, what if in Europe they say, we can't use diesel-powered rigs, drill rigs, after 2030? What would that mean to Keller as a business? What is that risk for us if in 2030 we couldn't use our diesel rigs anymore? That would be a big financial risk. So we run that scenario and then report that out so our shareholders and our stakeholders can understand what the risk is to us with the transition to a low carbon economy. Another way we look at it is physical risks. So we run scenarios saying, what if we don't, as the world, we don't meet our Paris Accord agreement saying we want to cut carbon emissions to limit warming to 2 degrees C. So in 2050, we have 2 degrees C, 3 degrees C, different warming scenarios. And then how does that impact us as a business? And obviously, it puts a lot of risk on how we operate in places like North America and Australia, where we have hurricanes, excessive precipitation and flooding, like I showed you with that chart from First Street, and then heat for our employees and wildfires as well. So TCFD is a complex framework, but it's really useful to see, as an investor, as an employee, as a stakeholder, how are companies really preparing for the future? Another driver is client demand. This is really interesting because we have clients who are just setting their own requirements. They don't have to do it, but they want to do it. So Turner, sorry, let me get a drink. Turner is a giant construction company. Many of us work for them, whether as a designer or a contractor, and they have decided to say and set the target to be net zero by 2040 in scope 3. Again, I'll define those scopes a little bit further and just. But what's amazing about this is it's not 2050. They're saying net zero by 2040. That's not too far from now. Another case of an owner is Microsoft. So here we have a software company that actually builds a lot of infrastructure. Many of us are working on data centers for companies like Microsoft. Microsoft has an environmental sustainability report where they're highlighting that they are going to do their own alternative material research, and they want to enhance precision in reporting on material embodied carbon. So here is an owner, a software company that's going to drive changes in how we design and how we build. And I also want to link legislation and client demand. This is going to be big with the new European legislation, which is the Corporate Sustainability Reporting Directive, CSRD for short. You're probably going to hear more about this because it's pretty extensive guidelines on how companies need to report that operate in Europe, not just being listed in Europe, but operate in Europe. So that's many of our clients and owners. So the legislation is driving, in a lot of cases, this client demand. And we see that from the Associated Geotechnical Contractors Playbook. They just issued on decarbonization and carbon reporting. What they're saying is understanding that the regulatory pressures are going to push our clients into requiring more carbon accounting and carbon reduction. We're going to see this more and more, and we're going to see it in requests for proposals. So it's really coming in lots of different directions, but a lot of the drivers are related. Okay, so that's why we should do it. Let's talk about how we can do it and the resources and tools for you. So the European Federation of Foundation Contractors and the Deep Foundations Institute recognize that our members don't really know what to do, which is why I'm here talking to you, but how do we address sustainability and how do we make this difference? So we decided to come together. The EFFC started this, the DFI has joined in issuing sustainability guides specific to our industry and following the United Nations Sustainable Development Goals. So this is kind of our roadmap of what we plan on doing and what we have done. So currently out for issues, EFFC only, Carbon Reduction Guide and Circular Economy Guide. We'll be issuing that joint with the DFI with more North American information shortly, hopefully in January. We're working on a water guide. It's almost done. And then climate adaptation and resilience are close as well. So it's a huge effort. Lots of volunteers spending a lot of time putting these guides together, but they're really helpful and they're really meant to be very practical and how you can get started now on what we need to do for sustainability. So I'm going to walk through the two existing guides for you just to show you the flavor of what they say and what they can provide for you to get some quick wins. So we'll start with the Carbon Reduction Guide. This addresses UN SDG 7 and mostly UN SDG 13. So the guides kind of all are set up the same way, starting with, this what, why, how measure approach. With carbon reduction, starts with what does climate change mean for geotechnical companies and why should we decarbonize? Lucky for you, I've already covered that. So you can skip that part of the guide. And then you can move to how can we decarbonize? So that's kind of the nuts and bolts. So when I talk about decarbonizing, I just want to give you some background because I've already mentioned some terms you might not be familiar with. So when we say as a company we want to decarbonize, we use these terms scope 1, scope 2, and scope 3 emissions. This is coming from the greenhouse gas protocol, and it aligns, which is kind of the basis for sustainability accounting and reporting for publicly listed companies. What we mean when we say scope 1, 2, and 3 emissions and why they're broken up that way is scope 1 are emissions from fuel. So it's a product that we purchase, but most of the emissions occur at the point of use when we're using it as a company. So this is diesel for the rigs that we have on site, diesel or gasoline for the vehicles that we own as a company, and also things like natural gas that we burn in our offices or shops or yard for heat. So we account for all of that fuel and then report those greenhouse gas emissions as scope 1. Scope 2 are the emissions from electricity we use. So this is a little bit different because we're paying for this service, but the emissions from the electricity occur at the power generating station. So it occurs somewhere else, not at the point of use. So here, again, it's directly within the company because we're paying for it, but it's happening somewhere else. So that's why scope 1 and scope 2 are split up in that way. And then we have scope 3. For geotechnical companies, it doesn't matter if you're a designer or a contractor, scope 3 is going to be our biggest point of emissions, according to the greenhouse gas protocol. So what this is basically everything else that has to do with our design and construction. So the smaller part of it is transportation. So the fuel we need to mob and demob rigs to site, the fuel we need to get materials to site, the fuel we need to get waste off of site, things like business travel, flying to a meeting, flying to a site to do the work. That's all included. But the biggest thing is going to be the emissions from the materials that we use. And that's kind of typically you'd hear of it as the embodied carbon of the materials we use. So why this is scope 3 and why this is huge is because most of these emissions occur off-site, right? Long before we get the materials at our site. But they're very big because most of the materials we use are energy intensive to make. So this is how things are defined and how we talk about it. So when your clients say, we need to know your scope 1, 2, 3 emissions, it's because that becomes their scope 3 emissions. So this infographic is just explaining to you how it's built up. So a material manufacturer is going to have very large scope 1 emissions. They're burning the fuel to calcine the clay to make concrete or make cement. They're going to have a lot of scope 1, less scope 2 and 3. When we purchase that material, all of those emissions become our scope 3 emissions. Those are the embodied carbon. That's the embodied carbon materials that we're buying. Then the contractor is going to have more scope 1, right? Because we're burning the fuel and we're on site. If you're the engineer of record and you've designed this, then all of the geotechnical contractors' emissions become your scope 3. And then the owner gets everything. So as we move up the chain, of the people paying the bills, you're going to have less and less scope 1 and more scope 3. And then what that looks like on a site, just visually thinking, the diesel for the equipment is scope 1. If you're using electricity, it's scope 2. And then everything else is coming in at scope 3. So how can we decarbonize this and what does it look like? When we talk about this very large amount of emissions coming from materials, the embodied carbon of materials, these are what the numbers actually show. So if you're buying steel pipe as an example, if you had 0 recycled content, which is not common, you would have about 2 tons of carbon emissions for every already emitted for every ton of steel that arrives onto your project site. If you can get up to 100% recycled, then you're almost down to 1 ton of emissions per ton of steel. When we're talking about ready-mix concrete, cement is the most carbon intensive material in that concrete mix design. So if you're using 100% Portland cement in your concrete mix, so this is a standard 3000 PSI mix design, you can expect to have 0.35 or 350 kilograms of CO2 emissions per cubic yard. As you replace the amount of Portland cement, hopefully with things like limestone or fly ash, you can greatly reduce the total carbon intensity of that mixed design. Also for solutions that are basically like jet grouting or soil mixing where we're using straight cement, we can have a really huge impact again when we move to those alternative binders. And that's why there's so many alternative binders coming onto the market, because what we traditionally use, straight Portland cement, is extremely carbon intensive. And you can see the impact we can have by moving to things like slag, which is a byproduct or a waste product of the steel manufacturing industry. I also wanted to add stone. So I think a lot of times you'll hear us say, if we're talking about carbon intensity of foundation solutions, we'll say something like stone columns are a really low carbon solution compared to a traditional foundation, geostructural foundation. And the reason we're saying that is stone is just not, it doesn't have a lot of processing. And so we don't have to, use the kiln to calcine the clay. We don't have to use an electric arc furnace to produce the steel. And that makes a huge difference. So when we look at a ton of stone, the emissions are orders of magnitude less than concrete or steel or cement. So I just want to give you a flavor of what those are. I'm not saying we can't use steel or concrete or cement, but just recognize the difference in those emissions for those materials. So when we think about reducing emissions in the materials we use, we like to use the carbon hierarchy. It just gives us a good concept, right, to follow. Okay, at the top, eliminate. Do we need this foundation in the first place? And believe it or not, we do have situations where we say, we have to go to the client and say, we actually don't think you need a deep foundation solution. It does happen, but maybe we can eliminate it. Maybe we can do a Teams meeting instead of fly. Maybe we can just simply eliminate the concrete, cement, or steel from the solution. That's the first step. If we can't, then we move down. Okay, we need this foundation, but now we're going to reduce the amount of materials we use. This is smarter design, more analysis, clever design to say, okay, can we reduce the number of piles and pile diameters? Can we improve the efficiency of our process on site to reduce materials and also reduce fuel as well? Once we do that, then we can get to substitute. So this is what I was saying before with the substitution of materials. How much Portland cement can we replace with slag or fly ash? What can we do with renewable diesel as an example as a replacement for fuel? Substitute is below reduce because we don't want to waste these important alternative materials. Just because slag is low carbon doesn't mean we should use as much as possible. We need to have that clever design, reduce what we're going to use, and then do the substitution. Then at the end, you can compensate with high quality carbon offset. So when you go to the guide, you'll see these key ways to decarbonize materials is reduce material quantities, like we just talked about with that clever design, substitute the low carbon materials, also focus on reuse of materials. For example, are they doing demolition on that site and they're crushing concrete? Can we then use that crushed concrete in our aggregate piers? And then lastly, engage with suppliers. We'll talk a little bit more about this, but engaging with your suppliers to say, hey, we want this material and we're going to be using it in this area. This is something that's important because I notice when I want to use, when I tell our engineers or project managers, go use this low carbon material, they say, well, I can't get it. It's not available here. So we need to engage with our suppliers so they know we want it. Next is procurement. Some key ways to decarbonize through procurement are incentivizing your supply chain. So if you're going to do a big project and you're putting out an RFP for concrete, for example, increase the weight applied to low carbon materials. Work with your client or the GC or whoever you're working for as the designer to say, hey, we want to make low carbon important, maybe even slightly more important than cost. You can set minimum standards, and we're seeing that with companies like Microsoft. I showed you as an owner saying, we want a 30% reduction in carbon right off the bat. That's going to be the minimum standard for this project. Consider these long-term partnerships. So I was just saying, engaging with their supply chain. They need to know that if they're going to bring in alternative materials, set up the infrastructure to bring and the logistics to bring in something like slag to a new market. Are you going to want that slag next year and the year after that? We need to engage with them and have these long-term partnerships saying, yeah, we want you to do this, and we're going to continue to use it. That includes things like we're going to make efforts to make sure that's approved in the code or, by the municipality. Also look at leasing and rental options to allow earlier adoptions of new technologies. I already talked about hybrid generators. You don't have to buy those, you can rent them. Or things like a new rig. We could buy a diesel one, but maybe we could rent an electric one and see how it works before we actually extend a purchase and put the capital into buying one. So consider like kind of clever ways with procurement that we can try things out and see how they're going to work in the future. Also, we can request products with lower carbon footprints. And the way you know that that is happening is through environmental product declarations. So this is going to be really important for your procurement teams. You may see this coming, particularly for lead projects, projects with federal funding, projects with clients that are publicly listed, particularly if they work in Europe, and companies that operate in California. Environmental product declarations are provided by your suppliers, but also they can be found in databases. So ASTM has a great EPD database, and Building Transparency has one as well. There are more. These are free. These databases are free to use. They also have higher levels of EPDs. So things like higher tiers of EPDs. And this is where a supplier will say, using my product actually saves X amount of carbon compared to the baseline. And this could be really useful for people that are new to carbon reduction to say, oh, now I understand, like the different process that they're using actually reduces the amount of energy required. So what does an EPD look like? Here's a standard EPD from CEMEX that's just off the ASTM database website for a 4,000 PSI concrete. It's actually a full life cycle assessment, which I'll talk a little bit more about. So it's giving you lots of information. But when it comes to carbon reduction, the key thing you're looking for here is the unit. So in 1 cubic meter of concrete, I'm going to have 426 kilograms of CO2 equivalent emissions. And that's the key. That's the carbon that you're looking for to help you make assessments on how much carbon you're using, and also to meet the requirements for your owners for the EPDs. Okay. Transportation work sites and electricity. I'm going to let you read the guide on those. I know we're running low on time, but I do want to talk about measuring progress. So when I'm telling you to go out and cut carbon, how do you do it? It can seem overwhelming. Doing a life cycle assessment, which is the background of those EPDs for the materials, doing that for our own projects is extensive and it takes a lot of time and it's difficult. It's unlikely to be done on something unless it's a very big project with an owner who wants it. LCAs are great. They give you all this information, as you saw in the EPD. It's way more than carbon. But as I said, I think carbon's a great place to start. So just focusing there can be really useful because it's a little more bite-sized and we get something we can get done today. What I recommend you use for our industry is the EFFC DFI carbon calculator. It's industry developed and accepted. It meets the ISO, GHG, and PAWS standards. It's Excel-based. Probably likely moving to web-based in the next year or two. It's cradle to gate. That's saying from raw material extraction to getting those materials to site to installing them in the ground, handing that foundation solution over to our client. It covers all of those emissions. And so it's reporting scope 1, 2, and 3, and it's doing that in carbon dioxide equivalents. The best part is it's free. You can go to geotechnicalcarboncalculator.com and download this and the guide. There's lots of videos online as well through the DFI or EFFC on how to use this calculator, so I'm not going to go into that here, but just know it's available and it can provide you that detail, that measure of, am I actually doing better? And that's why I like it. Because using these emission factors, they're updated every 2 years. You know you're on the right track. You can input the EPD material-specific information like I showed you. But it also is for our industry. So they've done the research, they've done the case studies to say, hey, if you're doing a drilled shaft solution, likely 95% of your emissions are coming from your materials. So if you're going to reduce carbon, you should focus on your mix design. If you're doing something like stone columns, stone's that low carbon material, here maybe it's more a better use of your time to look for renewable diesel. So it's really nice. It also provides simplified ratios. So if you're a designer and you don't know how much fuel would be required for a stone column solution or mob demob or the asset depreciation and how you would allocate carbon for the equipment that we use. For certain more common techniques, this tool has simplified ratios to say, hey, this is what we expect. If you know how much stone you're using, then you can estimate that this is how much fuel is going to be on that site. So that allows us to get early information even before the project is too far down the line to say, hey, this is where we need to focus. Okay, so what is this carbon calculator asking for? Typical information that you would have in the design or a contractor would have in their estimate. Material quantities, the amount of diesel we're using, where things are coming from and how they're getting there, where the waste is going, and then the weight of the equipment. All it's doing, an actual carbon calculation is not that complicated. It's just the quantities times an emission factor. The emission factors are what's hard. So that's why this tool is so great. It's providing you those current emission factors. You don't have to worry about trying to find them. And then it's outputting the carbon emissions. So all it's doing is 100 tons of cement, you input that, it knows the emissions factor per ton of cement, and then it outputs the total quantity of emissions that you're going to have for all of these things. I want to know, if you're a designer and you're not sure about many of these things, here's the hierarchy. Materials, like I showed you, is going to be the most important thing. Then diesel, if you can figure it out. But the other things are likely not going to be as important when it comes to the total carbon. Not that we don't want to reduce them if we can, but really you're going to want to focus on material and then energy. There are other areas to reduce carbon. We do want to focus on site selection, site characterization. We want to have that lens of carbon focus when we go to design. Think about load testing. That can help with the factor of safety and reduce risk. You know, if we go to a site, we don't know if the foundation solution is going to work and we have to make a change in the field, it's going to cost a lot of carbon. That's just how it is, right? We have to get it done. So as much pre-planning as we can do to better understand the site, the better we're going to be. Also, moving to performance-based design is going to be key. So what does this actually look like? I'm just going to do a quick case study showing you the power of carbon calculations and EPDs, and that is one. So this is for just an example, micropile project in the Northeast of the United States. We ran through material quantities, fuel, all the other details. You can see how material quantities and fuel are really driving the whole design. So we don't need to worry as much about these. But this was an interesting one because the steel casing, we didn't have a mill certification for. So we assumed 95% recycled content. But really, we knew that steel casing was repurposed, but we didn't know how to account for that. So luckily, we now have an EPD from our supplier, John Murray Tubulars, and we can go in and say, okay, for 1 metric ton of that pile, here is the emissions that we can use to calculate our carbon footprint. And now we can put that into the carbon calculator and you can see it's a reduction in carbon emissions. Well, also it's the more correct answer. So we know where to focus. And this is just the power of using the carbon calculation and EPDs together. So lastly, I want to touch on the circular economy because this is another resource available to you. This guide was issued by the EFSC, but will be reissued in January by the DFI as well. And this is just another up-and-coming area that we hear about and related to sustainability that I think is important for the geotechnical industry, but also a place we can make a lot of improvements. And this is really focusing on SDG 12, responsible consumption and production. So what is the circular economy? I guess it helps to know where we're starting, and that's with the linear economy. So what we have now typically is raw material extraction, moving through manufacturing, coming to our site, installing a foundation, it being used, end of life is likely staying in the ground or the landfill. What we want is to move to the circular economy. So that's basically saying, how can we eliminate that end of life landfill and either recycle, reuse, or refurbish? And that's the point of the circular economy, limiting manufacturing of new materials to just lower our impacts and help us live within the bounds of our ecological system. So the circular economy 3 principles are eliminate waste and pollution, circulate products and materials at their highest value, which I'll talk more about, and then regenerate nature. In this guide, we're mostly focusing on 12, but you will see the knock-on effects for 6, 13, 14, and 15. But I just want to mention that it's a little bit less about regeneration and more about the first 2. Okay, so who's driving circular economy? Where is this coming from? We do see it from clients setting internal sustainability targets. It is part of the new legislation coming out of Europe for the Sustainability Reporting Directive. There's actually a circular economy module within that. We see that in things like the federal Buy Clean initiative, where they're pushing for recycled materials as well. Also, what's cool about the circular economy is it can reduce demand for materials, which can reduce costs and also reduce risk regarding our supply chain. So it's similar drivers to carbon reduction, but a little bit different and a little bit more specific in some of these areas. So again, we have a great hierarchy for the circular economy. How do we do this in practice? It's using less resource, starting with efficient design, like we were talking about with carbon reduction, but then circulating at the highest value. So how do we reuse things like sheet piles? Steel is infinitely recyclable. How do we keep it in the economy? Eliminating waste and pollution, and then disposing responsibly. So quick wins for the geotechnical industry are reusing spoils on site. I think most of us as contractors or designers are trying to do that, right? How can we keep the material we're pulling out of the ground on the site and reuse it? This is a big thing for linear infrastructure like roadways, but also we can do this on our sites as well. I mean, should really focus on it. Why take that material somewhere else when we could use it on site? Reusing drilling fluids, recirculation is really important. Here is spoils separator that we use in Europe at Keller. Also reusing materials. We have waste pipe, aggregate, demolition waste. We can use those things like we talked about repurposed pipe as well. We can use them and keep them in the economy at their highest value. Use trading and reuse schemes. So this can be internal or external. For example, we have a piece of equipment we're not using anymore. Maybe another division of my company could use it, or maybe another company could use it. So keeping that equipment, as long as it's operating efficiently, in use instead of sending it to be scrapped. And reducing waste and consumption. So again, better design and waste reduction. So I did say circulating things at the highest, materials at their highest value. I just want to mention what that is. So recycling is what we want. It's the coveted highest end, right? Converting materials into something with the same value as before. We can think of that in the metals industry, particularly aluminum, recycling right back into aluminum. Downcycling is the alternative, and that's better than nothing, but also less preferable. So downcycling is recycling something into a lower quality. So for example, many of us know plastic cannot be recycled infinitely. It can also not be recycled at the same highest value. It's downcycled. So a bottle could be downcycled into fibers that can be downcycled into plastic lumber as an example. So downcycled is not as good. We want to stay in that highest level of circularity. And that's why it's so important to think about things like steel. Should we put it into the ground? If we have an alternative, it should probably stay out, because once it's in the ground, it's likely never going to come out. So what are the big implications? Reuse of foundations is a big one. Like I said, it's in the ground, it's likely not coming out. There is a great geostrata whole geostrata issue covering foundation reuse. You can reuse the foundations as is. You can do testing and analysis, or you can do additional support with new foundations to keep those in use. But more importantly, for those things that are going into the ground today, can we plan for them to be reused by keeping good records of our foundation installation? Could we even sell those records in the future? And can we innovate around this concept? So this is interesting from Caltbray with their hyperpile out of the UK. One of the key features of this new pile solution is that it's reusable, helping to support the circular economy. So quickly, I have 1 minute, I think. My final thoughts are we can reduce carbon on every project. Many carbon reduction efforts will save cost and or schedule, because oftentimes we're doing things in a better, smarter way. But also remember that it's okay to start with carbon reduction as a focus, because you'll also positively impact other SDGs. There are challenges. We need to support innovation, new ways of thinking. Changing designs late in game is difficult, and sourcing materials, as I mentioned, can be hard. But also let's think about, in terms of circular economy, presenting different ways of thinking and how we do things, for using materials at their highest value, and also thinking about foundations retaining their value beyond their initial life, and how we can build now with the future in mind. So I think there's bigger target for sustainable development than I originally presented. It may not be as hard, but hopefully now we think of it also with the circular economy encompassing it as well. So here, I just want to say quick thanks to the DFI Sustainability Committee, the EFFC Sustainability Working Group, my colleague Luke Deemer, and Bill Bailey from John Laurie Tubulars. That's it.
Surprise, you get me instead of Christina, because she went off to start the afternoon session. So congratulations, everybody that's still watching. Great presentation, Kimberly.
Thank you.
if you've got time, we can do a few questions. I think Christina had one, I had one, and if you're watching out there and you've got anything you'd like to throw at Kimberly, just put it in the chat box, and we will ask it in due course. So we'll start with Christina's here, and I'm going to have to scroll up to find it real quick. Are any states besides California implementing carbon reduction legislation? I guess these are two different ones, so we'll just start with that one.
Yeah, sure. Yes, we see it in New Jersey, New York, kind of up and coming things out of Minnesota as well. I'm going to say this, and it sounds weird, but there's a website called Desire. I actually need to know how to spell that, but basically,
yeah, that could be a situation.
It's a weird name. But it does tell you all the legislation and all the also incentives available on a state-by-state basis. So it's very useful. I know I hate to ever mention that name because it's really weird, but it is a thing and it is legit. But yeah, we do see it growing. We do see it expanding. New Jersey has low carbon concrete basically incentives for tax reduction for owners. So there's things like that that are already in the books as well.
Very good. I think her other question, so this is more of a corporate one. How are construction companies responding to carbon reduction efforts in their projects?
It depends. We have some of the really big, like Turner, like I showed in the talk, Turner Construction, the big GCs really getting on board, understanding this is what many of their clients are looking for, but they're working for those higher level clients and they're driving it. On some of the kind of more developer driven projects, you're just not going to see the client demand there. So it makes it hard for the contractors to move in that direction. But I think you see with all the new legislation, particularly coming out of Europe and California, that our clients are just moving in this direction. And there's quite a few general contractors, at least, that are just going, just sticking with it and moving to more sustainable solutions and being able to report and provide the information necessary to those clients.
So I want to ask you about materials too. I feel like we're kind of at an interesting place in 2024 where it's not like it was 20 years ago where you had new nanomaterials coming out that were really outpacing any legislation and regulation. And it, not necessarily so much in construction, but in science and engineering in general, it was a little bit Wild West if you wanted to use that stuff. How do you feel about new material development now, especially as it relates to sustainability? I mean, I feel like we're in a decent place where people are ready for this stuff and can regulate and legislate it quickly and get it out into the market. What do you think?
I would say that it's an exciting time for sure. There's so many startups in low carbon construction material space because people see this as a key initiative and a key way of reducing global emissions. We all have seen the statistics that cement is, responsible for 8% of global emissions. So there's definitely a desire there. What's also interesting is those materials, if they use less energy to be produced, then they could be cheaper. So it may not be a trade-off on the economics, which of course makes adoption easier and more interesting and more appetizing to some of our clients. But it still can be difficult. There's still questions around how consistent those materials can be. Even slag, it's such a well-known alternative binder. Fly ash has the different classes. Slag comes in different particle sizes, but depending on the source, it can have different things in it. Depending on the municipality, you can have different regulations around using it. So people are just so used to using Portland cement that any changes actually can be a little bit shocking and hard. Even moving to type 1L with the limestone, as many of our cement suppliers have done, it changed the way we had to do some things, even at Keller, and we hadn't expected it. So we just have to be prepared and be more agile. Getting adoption, I think is coming. ACI just issued a low carbon concrete guidance document, which is useful. But some of the true alternatives, it is hard, right? We build for civil engineers. We build for 25, 50, 100 years. Can we prove that it's going to be there when it's a product that's 5 years old? right? We have to make
Well,
sure
I guess
that
it kind of
we
goes
can do
the
that.
other way too, right? You mentioned Portland cement. You know that that's going to be fine in every county in the US and Canada. Like there's no county out there, I don't know, I hope there isn't because I'm saying this, that says you can't use this in X form or whatever. But you gave the slag example, and that's a really good one. Like it really is a patchwork. It's very different all over the place, what the mix can be and everything, what's allowed. So I think it falls back to simplicity too, which I think the last time we had one of these conversations was one of the questions I asked is, I'll ask you it again, and this can be what we wrap up with. For a lot of smaller companies out there who watch a presentation like you just gave and say to themselves, well, this is too complicated. I can't possibly do any of this that would really make a difference. So why should I bother? What is your message to those people?
I may be frozen, but I can hear you. Can you hear me?
I can.
Okay. Yeah, my message is, look to these guides. They'll give you the quick wins and things that you could do today as you're learning about more things that are available. I mean, it's really up to you. The legislation's coming, client demand is here, and it's going to get bigger. Just preparing yourself and your company is a way to do it. Get the upskill and learn about it. It does in some ways feel like a heavy lift, but the more we learn, the more we can tell our clients, hey, if we do this extra site investigation, we can reduce the factor of safety and or reduce the amount of foundations that we have to put in, but also reduce your risk. And also we could try out this alternative material. So it's kind of building on things we already know, but presenting it in a new lens to our clients, not just to save money, but also to reduce carbon. I think our clients are interested in that. So we can I think for the smaller types of companies, maybe smaller projects, it's kind of just finding those ways to get in and start to make a difference. And then as you learn more about it, it's easier to sell, right? You'll have more data backing things up.
So that's perfect. So we can wrap up with that. Great job today, Kimberly. Thanks to our viewers for sticking around here till the end. If you liked what you saw, and you probably did because you're still here, again, click like, subscribe, and get notifications, and we will notify you every time we post something to the YouTube channel. A couple of things. The web conference is continuing all throughout the week. It's only Tuesday. You could go register for those other fantastic sessions. Just head over to Geo-Institute.org, go to the events page. It'll be right there, and you can choose which sessions are of interest to you. Hopefully, you'll pick all of them. Our last live stream of the year is coming up next Thursday. It is GeoStrata Extra for the month of December, well, for our December-January issue, which you can get at readgeo.com. The focus is on QA/QC, and we're going to have a fantastic interview next Thursday on that topic. So thanks again, Kimberly, and thanks to Keller for sponsoring the web conferences this year. And you were freezing up, so we lost your video, but I know you're not muted, so I can see that you're still there. So thank you for presenting today.
Thank you for having me.
And for everybody else, we will see you very soon with another Geo-Institute live stream.